Jumping into the last new skill, if you will, of our simultaneous equations unit. So today we're going to look at three-part simultaneous equations. So you're going to see hopefully by the end of this that we can use the same methods that we've already been using, our elimination, our substitution, and our graphical methods if we so choose. Graphical probably a little bit less useful for this one. So we're going to have a quick look at an example. Then I'm going to get you to try one on your own, which I've gone through the solution for, and then finally I've got a more complex example at the end. Now, as there's a lot of writing for these, I'm going to try and use a lot of stuff that's pre-written, but I'll talk over the top of it, so hopefully it will make sense. And as always, feel free to pause, go back and review if you need to. So let's go to the first example. So when we say three-part simultaneous equations, normally we've seen x's and y's, we've seen two or more equations like that. Here you can see we've got x's, y's and z's, but we can still use elimination and substitution and our kind of upscaling to help us with this. So when we look at this set of simultaneous equations, sometimes Americans call it a system of equations, so if you see that anywhere, that means the same thing as this. We can see that we've got no common factors at the moment. And we do have that red equation where we could maybe rearrange to make y the subject. But just for this first example, because most of you said that elimination was your favoured method, I'm going to show you how you can use elimination. So I'd look at the x's and I'd say, okay, there's 4x, there's 2x, and there's negative x. And 1, 2, and 4 can all quite quickly and easily be made into a common factor. So I'd look at these and you can see I start with the equations in the top left. And we've changed each of them, I've color-coded them so that you can make them into the equations that you have. So, what we can do here is we can say you've got 4x minus 3y plus z, well that's already 4x, we can keep that as it is. The 2x plus y plus 3z we can multiply by 2, so the red equation multiplies by 2. Be careful with equations equal to 0, because you can see obviously that it's still 0, because 0 times anything is 0, and then we've got the green equation we've multiplied by 4 to get negative 4x, 8y, and 20z is 68. So now we've got that common 4x in all three of them. We've talked about this before with the elimination method. It doesn't matter if it's negative or positive as long as the numerical value is the same, so it's negative 4, positive 4, we can eliminate by addition, and the positive 4 and positive 4 we can eliminate by subtraction. We've got three equations, but what we do is we split it into pairs. So I'm going to pair the blue with the red and the red with the green. You could have also paired the blue with the green. It doesn't really matter, but you're just going to choose two pairs and then you're going to eliminate in the same way that you've done in the past. So I chose the blue and the red, and I've got a 1 positive 4x and a negative 2 positive 4x's, so I'm going to subtract them from each other to eliminate the x's. And by doing that, we get the 2y minus negative 3y, and negative negative makes it positive, that gives us 5y, and 6z minus z is 5z, and 0 minus negative 10 becomes positive 10, and then we did the red and the green. This time we added because we had a positive and a negative, so we need to get them to 0, so we did positive 4, negative 4, and then 2 and 8, and then 6 and negative 20. And when we add those together, we get 10y minus 14z is 68. So now at this point, we had x's, y's, and z's. And now we've changed that, so we've only got y's and z's. So we've got two variables. We've eliminated one of them. By doing that, we've created two equations similar to the ones which we looked at in the previous video. We've got two equations, two letters, and we can solve them in the same ways that we've done before. Here I'm going to look at 5y and 5z is 10, I'm looking at 10y and negative 14z is 68, and all I'm going to do is say, okay, 5y, 5z, I know that 5y, 10y, 5 is a factor of 10, so I'm going to multiply the 5y plus 5z by 2, and that will give me a common factor which I can eliminate. You can multiply, not highlighted. We can multiply by 2 to get 10y plus 10z is 20, and then we've got that common 10y, which we can eliminate. So as before, we eliminate, and when we eliminate now, we're going to get down to just one variable. By subtracting the two equations, being careful of our positives and negatives, we now end up with z is -2. So now we have a value for one of the variables. And we're going to continue in the same way that we have been doing in the past. We take that z and we're going to put it into the two equations. But be careful which ones you use. We've now got these two that I've kind of color-coded purple, and they're the ones we're going to use until we found two of the variables. We found one z, we're now going to use that z to find y. So, I've jumped a bit too far ahead. So, we're going to substitute z is -2 into those two equations. So as you can see, I've shown the subtractions again, how you got those purple ones, and when you've got those there, you substitute the values in. So z is -2, which went in here, and z is -2, which went in here, and then we expand the brackets and cancel out, and you'll notice that for both equations we end up with y is 4. Now if we substitute it into both of them and we get the same answer, we can be confident that those two variables are correct. If you don't get the same answer at this point, then something's gone wrong with whatever your first variable is, so you need to go back and review what you've done. So now we're pretty confident that z is -2 and y is 4. Now we've got to jump right back to the beginning. And we go right back to the original equations in the question. Now we know two of the variables. What we can do is we can substitute both of them into all three. Now I know this is a lot of work, but don't worry, you won't have to do many questions today. Okay? By putting those two into all three, so wherever we see z, we're going to put in z here, we're going to put in y's here, and we're going to end up with just x's left over. So we're going to eliminate two of the variables from each question in one go. Now that's a lot of writing, so I'm just going to kind of skip to where we do it. Okay, and you can see I've color coded it. I put z's in where the yellow is and y's in where the blue is. By doing this, we can see that the only variable that's going to be left once we tidy this all up is x. So we do -3 times 4, we do 5 times -2, we do all the multiplications. Be careful of your positives and negatives, and it will look something like this. So in the first equation, the blue one, -3 times 4 is -12, subtract the 2 is -14, that's this bit here, and then we can add 14 to both sides, you get 4x is 4, and we get x is 1. We do the same thing here, the 4 and the -6 make -2, we add 2 to both sides, and we get x is 1 again, and finally we do 4 minus -10, which is plus, so we get 18. We add 18 to both sides, subtract 18 from both sides, and we get x is 1. We've got the same value of x in all three equations, so we know that those three now work in all three. So we know that x must be 1, y must be 4, and z is -2. We can answer then as a 3D coordinate. So that is what we've given. So still answering as a coordinate, that's what we've got here. Okay, x, y, and then we add the z. So now we've given a three-dimensional coordinate with those values. So let's go a quick recap, because there was a lot of stuff we covered there. We start with the equations. You can use elimination or substitution. I chose to use elimination. You could have also used substitution by rearranging for this y here if you chose. Doesn't matter as long as you do each method thoroughly. I chose to do elimination, so I made the 4x's the same, I made them all 4x by multiplying or dividing. Once you've got that, you can choose pairs, so I chose red and blue, red and green. I could have chosen blue and green as well. Remember to add and subtract at the right times. I then got an equation with two variables. I solved them as we've done in the previous lessons and in the quiz by, again, elimination. Could have used substitution as well. You put the value of z into both equations, that gives you y is 4. Once you've got two variables, you can then put those two variables into all three, notice it's the ones we started with, and then You put them in, do your multiplications, and in theory, if you've done it right, the most important thing is that at the end, you get 3 of the same answers for all 3. And at that point, hooray, it's all gone well. Great job. So, like I said, that was the example. Now I'm going to get you to try one on your own. So I'm going to show you the question. Here's the question I'd like you to try. I'd like you to pause the video and try this set using elimination or substitution. So pause now. Okay, hopefully you started again and you want to check the solution. So I'm going to show you the solution in a second. Well, I'm going to show you the answer and then I'm going to show you the whole solution. What I'd advise is when I show you the solution, you just pause it so you can read through. So if you did it correctly, you should have 2, -1, and 1. So well done if you got that. It should have looked something like this. So I'd advise you pause now and read through this. I'm just going to talk through a few steps as well, so you might want to listen to that and then pause it. So first thing I did was I looked at the blue equation. I realized I had a y and a z. And I also looked at the y's and realized I had -2y and +2y in the red and green. So I decided to use elimination again, but I also could have used substitution, and I'll show you an example of that in a minute. I made that equation in pink, so I had 2y, and then I added the red equation and added the green equation to the pink each time, red and green and pink and red. I then got x's and z's for both. I had 5x plus 5z is 15, -2x plus z is -3, and at that point I decided to rearrange so I could substitute my value in because I had that nice positive z. I put that in here, and then I expanded out the bracket, and then we got that value of x. Once I got the value of x, I put it in to my formula to get the value of z. Once we had x and z, we then put them into all 3 equations, the red, the green, and the blue. And then once I put them in, you can see I got y is -1, y is -1, y is -1. So I knew that that must be correct. So you get x is 2, y is -1, and z is 1. Okay, so one last thing to go through then. I'm going to go through a more complex example. If you're thinking pretty confident with this, the next one coming up is kind of at that master exemplary level, so it is quite a tough question. Feel free to, probably is an exemplary question if I'm honest, so feel free if you want to challenge yourself, you could always pause and try the question yourself before I go through it, and then you could play again and see if you got the answer right. So here's the more challenging question. Feel free to pause now and have a go, and then you can always play again and follow the solution through. Now you'll notice in this question that we've got a slightly different format. We've got x's and z's, x's and y's and z's on the left, and then we've got variables and numbers on the right. We've got like a more balance. We've got 2 terms on the left, 2 terms on the right instead of x's, y's and z's. So it's a little bit more challenging, but we can still use elimination and substitution method in tandem to solve these problems. So if you were trying it yourself, you should have got -1/2, +3, and -4. So if you at this point got that one correct, I'd say you're quite ready to just stop the video and try some of the questions I've set the 2 quizzes is. But if not, then feel free to continue watching and I'll go through this solution. So again, another one where I'm going to show you the whole solution. It is quite small, so you might want to pause it, zoom in, screenshot, etc. And I'm going to talk you through this one. So I looked at the blue equation, and when I looked at that, I realized that if I collected all the variables on the left-hand side by adding z to both sides, I added z to both sides, so I got this z here, and then I realized I could rearrange to make z the subject. By making z the subject, I realized I could substitute x's and y's instead of z's, so I could eliminate z from different simultaneous equations. I took the green one and I put the z in here. I took the red one and I put the z in here, and then went through all the expanding the brackets. You can see the stages there, and again we ended up with a 2 variable equation here, y's and x's, and 2 variables here. It's important that you have the same 2 variables, y's and x's, y's and x's. You don't want to make an equation with y and x and an equation with x and z, because it doesn't actually help you. You need to eliminate them. So if I still had z somewhere, I haven't eliminated it. But now we've got to this point, I went, oh, excellent, I can do some positive y and negative y, so I'm going to use elimination. So again, we can see how we use both methods. We use substitution first, now we're going to use some elimination. Once we do our elimination, we add them together because we've got one negative and one positive here. And by adding them together, we cancel them out, nothing left. We get negative x, negative 8x is 4, so x is negative a half. And then we can substitute that in here, and we end up with y is 3. And just like we did before, we put it into the red, the blue, and the green. We get negative 4 all of the 3 times, which tells us we've done this correctly. Again, it's just simple substitution. It is a lot of working, but a lot of the steps are just adding and subtracting, multiplying, and maybe some dividing as well. So these are the things which, if you're not feeling confident with, and you can always use your calculator to help you with these stages. So once you've done that, we put the x and the y in, and we get that solution. Now this is an exemplary question, but you'll notice that it's not hugely more difficult than the ones we just looked at. The format that you get given the question is different, but we rearranged to get all the terms together, only for one of the equations. You don't have to do it for everything, and then we made z the subject. So when you look at more complex questions, don't start to think about how it's different and all the other things you need to do. Just think, maybe just look for one equation you can rearrange, or maybe just look for one variable you can make the same in all of them. Here, another method you could have used is perhaps looked at the y and said, okay, I've got y, negative 1, 4, and 2 are the coefficients. You could have made them all either positive or negative for y. That would have been absolutely fine. And then you can just deal with the other variables later. So essentially the idea is, instead of looking at it as this whole question with 3 equations and 3 variables, just look for one variable you can either make all the same, or one variable you can rearrange for. And if you stick to that, you should be fine. So that's 3-part simultaneous equations. Like I said, there's a good example of an exemplary question. It's probably maybe it's a tough exemplary question, so if you can do this one, you should be feeling pretty confident of this skill for when we do eventually, in whatever format, any sort of assessment. Have a go now. If you've got to this stage and you got that one right, you can have a go at the second quizzes, which has got some more complex equations that look a bit more like this, and hopefully you can solve those effectively. That page there, if you're thinking, oh, how should it look when I write it in my book? Okay, you can go back into this video, you can see that's roughly what it should look like, and that would be kind of a template answer. And if your answer's looking a bit less neat or a bit more frugal with not much writing, then perhaps you're not showing all your working. Similarly, if it's a lot longer than that, perhaps you're doing a little bit too much. So do compare yours to mine to see if they're roughly the same. And as always, I will be in the Google Meet room, so we can go through some questions together if you need to. Okay, enjoy these and rewatch the video if you want to go through any of them in a bit more detail.